All right, I'm back and it's time for another one of these challenges. This time I'm going to do blockchain technology. The reason why is because, okay, first of all, the reason why is because Bing AI told me to. But beyond that, I think it's a good topic because it's one of those things that's kind of like a buzzword you hear about a lot. But if you have no experience with it, and especially on the back end, if you have no experience with how the technology works, I think people actually practically have very little idea about what exactly it refers to, right? So maybe we can change that a little bit today. Maybe I can learn a tiny bit about what exactly we're talking about when people talk about crypto and people talk about blockchain. Maybe there'll be like some kind of pre-existing knowledge I can draw on here, but probably won't be as much as for things like with the NVIDIA one or with, what was it? Oh, the Eclipse one. So this one, on a scale of fractals being here, like knowing nothing going in or as close to zero as possible, and NVIDIA on this end, it's pretty much at fractals for, yeah, what I know about blockchain technology. All right, so I'll put the heading down, blockchain, and we're ready to go. So 3, 2, 1, let's begin. All right. So, oh wait, I forgot. I have to structure every time, right? So, what I'm thinking is for this, honestly, my structure will probably be a lot very similar to fractals and chaos theory, just because when you know very little about something, it's hard to know what questions to ask, even, right? So, I'm going to keep these questions very broad. I'm going to divide it probably into just 2 broad sections. The first one is the overview section, which you have to have every time, and the second one is practical applications over here. So in overview, this is like all about what is blockchain, how does it work? You know, you can always boil this down to the 5 W's, right? So who uses it? Maybe a sort of timeline like history. That's going to be the when, right? So what, when, who, where, how, where, and how. Oh, where? Wait, what? When? Who? Where? Why? Oh, wait, why? Yeah, okay. So why is actually an interesting one. I guess the why is the applications. Because it's like, oh, why did we develop blockchain? And it's like, oh, look at all these things we use it for, right? So, okay, so where, I don't know if that's that important. I mean, it's like online, right? But I guess we'll go over that when we talk about what. So, and then under applications, I don't know what all the potential applications for blockchain are, so I'll leave this a little bit open. But in terms of what I know we can cover crypto here, cryptocurrency, and also like NFTs. There must be other applications of blockchain too, but not stuff that I'm aware of right now. So, okay, let's just hope this is not overly abstract when we get into this. Let's search on blockchain. Not sure if I'm going to use the Wikipedia page because that might be overly abstract, I'll open it and skim it, but it might be very esoteric. It might be very complicated to try to understand, right? Other than that, I don't know what blockchain.com is, so I'm not going to open that. We're going to go into Investopedia and IBM. Coursera, you know, that would be great if I had 20 weeks to spend on this instead, but fortunately, I'm going to have to skip over that for now. So Investopedia, this is probably going to be pretty decent. Let's see. What is a blockchain? A blockchain is a distributed database or ledger shared among a computer network's nodes. Best known for their crucial role in crypto. I'll skim over this quickly. I'm not going to read all of it out. Okay, so I'm going to summarize 2 points from the first paragraph. This is talking about a distributed database ledger thing. Oh, and it's distributed across a computer network. Also, the idea that it can make data immutable, as in unalterable. Okay. Maybe we'll understand what that means more practically if we read more. Blockchains exploded via the creation of various cryptos, decentralized finance, NFTs, smart contracts. Okay, so I guess these are other applications that we can list down here. I don't know if we'll get into these, but decentralized finance is what DeFi. I don't know. I have no idea what that is. And smart contracts. It's a type of shared database that differs from a typical database in the way it stores information. Blockchains store data in blocks linked together via cryptography. See, this is the problem. This is so abstract. It's kind of like if you had to explain the internet to somebody from the 17th century, they wouldn't be able to understand it, right? That's how I feel about this right now. But maybe if I read more, it'll make more sense. Okay, familiar with spreadsheets, databases, blockchain is similar. It's a database where information is entered and stored, but the key difference is how the data is structured and accessed. Okay, a blockchain contains programs called scripts. Okay, this is an interesting part of it. A blockchain is distributed, which means multiple copies are saved on many machines, and they must all match for it to be valid. That's an interesting point. So it's saying that unlike normal databases, blockchains are saved on multiple network nodes simultaneously, and they all must match for the data to be verified. Okay, interesting. So I'm beginning to piece together in my mind how this might be able to like increase security or something like that. Okay, so the Bitcoin blockchain collects transaction information, enters into a 4 MB file called a block. Once it is full, certain information is run through an encryption algorithm, which creates a hexadecimal number called the block header hash. Oh my goodness. Okay. I'm getting the fractal flashback right now. Oh my goodness. Okay. It collects transaction information, enters it into a block, and once the block is full, information is run through an encryption algorithm, creates a hexadecimal number called the block header hash. The hash has been entered into the following block header and encrypted with the other information in that block's header. Oh, wait, this is actually coming together. I think I get that. So it's saying that cryptocurrencies. Oh my, okay, this is kind of melding together with the second part of this, but who cares? Cryptocurrency blockchains collect transaction data and store them in 4 MB files called blocks, okay? And then once those blocks are full of transactions, the block data is encrypted by an algorithm and turning it into a hash. And hashes, well, I'll write it here. It's a hexadecimal hash. Don't know if I'll have to explain hexadecimal while I'm talking, but if I do, I'll try to cover that quickly. So it turns it into a hexadecimal hash, and then that hash is then stored on the block header of the next block being created on the blockchain. So I think that's why it's called a blockchain, because you're chaining together one block to another. And so I think just intuitively, it feels like that would increase the integrity of the system if you have like a whole chain verifying transactions, right? But let's see. So in Bitcoin, your transaction is sent to a memory pool where it is stored and queued until a miner picks it up. Once it is entered into a block and the block fills up with transactions, it is closed and the mining begins. Okay, let me wrap my head around this. Okay, wait, I need to see what mining means in this context. I've heard of mining, of course, but okay, every node in the network, I'll continue reading because it seems like there's some information here. Every node in the network proposes its own blocks in this way because they all choose different transactions. Each works on their own blocks, trying to find a solution to the difficulty target. Wait, what? Oh, I probably have to read this first. What does that mean? Wait, a new transaction's entered. The transaction is then transmitted to a network of peer-to-peer computers scattered across the world. The network of computers then solves equations to confirm the validity of the transaction. What kind of, like, what, they just start doing calculus? Once confirmed to be legitimate transactions, they're clustered together into blocks. These blocks are then, okay. Okay, I mean, I don't know what they mean by solving equations, but I'll write that down anyway. Okay, I wonder what they mean by verify, but I don't know if we'll get into that at any point. Let's see, so every node in the network proposes its own blocks because they all choose different transactions. Yeah, each works on their own blocks trying to find the solution to the difficulty target. I don't know what they mean by that. The difficulty target? Using the, I'm assuming they're referring to the equation here, the equation they're all solving. Using the nonce, short for number used once. Okay, interesting. The nonce value is a field in the block header that is changeable, and its value incrementally increases every attempt. Every miner starts with a nonce of 0. If the resulting hash isn't equal or less than the target hash, a value of 1 is added to the nonce. A new hash is generated, and so on. What? The nonce rolls over about every 4.5 billion of attempts, and uses another value called the extra nonce as an additional counter. Oh, wait a second. I think I get this. If I'm silent, it's because I'm trying to piece it together in my mind. Oh, okay. Oh my god. So basically, if I understand this correctly, the block header, each block's header has, okay, I should probably be writing this down. Each block header has a value called a nonce that I feel like I'm missing so much context here. Hold on, let me see if like Wikipedia has something here. Like, do they have nonce on this website? Let me see. Bitcoin mining explanation. Let me look at this. How does Bitcoin mining work? Yay. Oh wait, this is also Investopedia? Oh, okay. Now, do they have nonce on this website? Yeah, okay. So miners are guessing a number that is lower than the... Oh my goodness. I think I have to start from here. Okay, mining is a complex process. In a nutshell, when a transactions made between wallets, the addresses and amount are entered into a block on the blockchain. Okay, yeah. And then we've included all this so far. So then it generates a hash like this. It has 64 digits. Okay, yeah, because it's hexadecimal. And then miners are guessing a number that is lower than the target hash. The target hash is a hexadecimal number set to require an average number of attempts. So like the system just generates this by itself, I'm guessing. Okay, we kind of get this. I'll put it together in my mind. This is so hard. It's fine. We'll get this. Miners make these guesses by adjusting the nonce, which is part of the information being hashed. User size limitations will not field the nonce is stored in. So the number for up to about 4.5 billion. Yeah. Oh my goodness. This is going to be such a short video because I have nothing to say here. It's fine. It's fine. Wait. Oh my god. This is so much information. It's fine. It's fine. So this is what a hash looks like. Okay. And for any single block, you'll have a target hash like this. And then the miners start generating hashes. Oh, wait a second. I think I get this, kind of. Okay, my god. This is my information on this is so tenuous right now, my confidence in this. But I think I can maybe put something together here. Okay, I want to look at this example as well. So it basically found this block. These guys found this block online, and it's giving you some information here. Yeah, why do you need miners too? Wait, I want to look at this first. The nonce that generated the winning hash was this. Okay, and the nonce starts at 0 and increases by 1 every attempt. So this was like 730 million. Okay, so this was the miner who mined it. As you see here, the contribution of the Bitcoin community is that the pool confirmed 1768 transactions for this block. Where does it say that? Oh, number of transactions. So this is how many transactions were in this block. Okay. I'd like to see all 1768 transactions. You can actually see them all. Okay. That's interesting. Why Bitcoin needs miners. You know what? At this point, I have like a little bit of a few notes, but I just have to soak up as much information as I can by skimming these articles. And then I just have to hope I remember it all. Let's see. So why need miners? So miners are getting paid for their work as auditors, right? So it's computational work that network nodes undertake to validate the information contained in blocks, conducting the first verification of Bitcoin transactions, opening a new block, and being rewarded for their work. Wait, 1 megabyte limit. I thought I wrote before there was 4 megabyte limit for blocks. Okay, I'll write here that Bitcoin might be different. And then, so, okay, yeah, why mine? So basically, I believe I remember this part. You get a reward basically every time you mine a block on the blockchain. Okay, I need to check one thing very quickly. How do Bitcoin miners verify transactions? What does that actually mean? Verify the transactions by solving a mathematical algorithm that represents the transaction on the block. Okay, I think I can kind of piece that together. And listen, this research part is going to be cut down probably like to 7 minutes or something, because this was really hard to take notes on. Most of the time I was just soaking up information, but this is what I've started to realize, that when it comes to something that's super abstract, that's really hard for me to wrap my mind around, it's difficult for me to even take notes, right? I think I have to work really hard to just get kind of like a basic understanding of what's going on first before I go forward. Something like the history of BMW is like super practical, right? But that's not to say these are bad things to research. These are probably better things to research because of the fact that they're harder to learn about, right? So anyway, can I talk for 5 minutes about this? I think I can, honestly. It'll just be like mostly information in my mind, but I'll use what I have written down as well, and we'll see how far we get. So let's head over to the speaking corner. And also, I mean, okay, I haven't commented on this yet, but the structure that I have over here on my notepad, obviously, I didn't get it done quite as much as I would have wanted to get it done. But, you know, you have to improvise, adapt, and overcome. That is what they say. All right, I think I'm ready to begin. Okay. 3, 2, 1, let's go. Today I researched blockchain. And let me tell you, it was super abstract, kind of hard to wrap my head around. Not like I've ever done an episode on something like that before. But anyway, what I've learned essentially, first of all, in terms of what blockchain technology actually refers to, it's at its core a decentralized database technology. So you might have a database, like standard databases that are stored locally on one computer, on one server, maybe at a particular location on the cloud or something like that. Those databases could be things like spreadsheets, or they could be stored in other file formats. But essentially, standard databases are single files that are stored locally, right? But the point of a blockchain is that it's a database that is stored collectively and in a distributed fashion among a whole network of computers rather than just one single location. And the other interesting thing about blockchains is that it also makes data immutable, meaning that it makes it so that data cannot be altered without, well, actually, it can't be altered at all. So you can kind of see why the decentralization and the immutability of blockchain makes it viable for certain things intuitively. So, for example, cryptocurrency, right? When you're trying to create a new payment services system, you want this system to have integrity, to be verified, to be secure. And the best way to do that, or one good way to do that, might be by having a decentralized group of computers that are verifying those transactions all the time, and also a system that makes sure that data cannot be like fraudulently changed once it's already been submitted. Right? Those would be useful characteristics to have in a database, in a payment services system. So essentially, what happens is, specifically regarding cryptocurrency, let's take cryptocurrency for a second, right? Every time a transaction occurs on a cryptocurrency system, I'm just using Bitcoin as a model for now, that transaction data is uploaded to the Bitcoin network, kind of, all the computers that are connected to and performing Bitcoin mining operations. And what happens is transactions are collected into either a 1 megabyte or 4 megabyte collection, a package, a file essentially, and that file is called a block. Now, this block eventually makes it onto the blockchain, right? And I'll explain what that means in a second. But before it can do that, you want the system to be able to verify that all those transactions are legitimate and not fake. They're not artificial, right? You want to make sure that they're verified by a whole group of people. So what happens is these transactions are uploaded into a block. When the block gets full, it gets sent to the network of Bitcoin computers, to Bitcoin miners. And these miners, all these computers, they work very hard to try to solve for a target hash. The target hash is essentially it's this long string of hexadecimal digits that are randomly generated. And it's randomly generated for a target level of difficulty to make it so that about one block, I think, is solved for every 10 minutes, something like that. But the way they're solved for is these computers have to use algorithms to try to generate a hash that is equal to or less than the target hash. And the way they're supposed to do that is by moving the nonce number, which is like one particular digit within the hash that they keep generating, up by one every attempt. And they run through something like 4.5 billion to 5 billion attempts every second. And so every time they make an attempt, that nonce will go up by one, and then it'll keep increasing, keep changing the hash that they're guessing with for every attempt. Eventually, somebody is going to get a hash that solves for the target hash, and they basically get the reward for the whole block. They get paid for the whole block, and that block gets verified, gets added to the blockchain. That hash then gets coded into the next block on the blockchain. And that's how the blockchain is verified, because it creates a chain, from one block to the next. Makes sense, right? Blockchain started in 2009, by the way, cryptocurrency Bitcoin. I meant Bitcoin started in 2009, okay? But you know what? I'm actually happy with that. I think that went okay. Like, at least considering how difficult that was, I think it went okay. So, as always, let me know what you thought. If you're a crypto bro, let me know what you thought. Flame me in the comments for getting stuff wrong, I guess. But yeah, also drop some suggestions if you have any. Otherwise, I'll see you next time.